Okay, so we're taking another look at the fundamental theorem of calculus, and there aren't going to be any new discoveries in this section. This is just another look at how integration works and how we talk about it. So here they're having us integrate the function x squared, here it is, between 1 and 3, so that would be 1 and that would be 3, and we know that doing this integral is equivalent to finding the area under this curve by adding up the areas of a bunch of infinitely thin rectangles to get a finite answer. And when we do this, we know that this integral means find the antiderivative of the function inside, which would be 1/3 x cubed. And then we can use a vertical bar like this to put the 1 and the 3 on it. And this means evaluate this function at 3, evaluate this function at 1, and subtract those two results. So you're doing f of 3 minus f of 1. And so if we carry that out, we get, plugging 3 into this, 3 to the third is 27, a third of that is 9, minus, then we plug 1 into it. 1 to the third is 1, a third of that is 1/3. And if we turn those into fractions, 9 is 27/3. Take away 1/3 and we get 26/3, which is the same as 8 2/3, which is the same thing that they got when they did this electronically. So it looks like integration still works today. Talking about notation for just a second, up here, the function that we integrated, what we call the integrand, is usually just written as f of x, and its antiderivative is written as capital F of x. And so when they're writing the fundamental theorem of calculus, they'll do this and they'll say that what you're evaluating down here is capital F of x, where, and they write it as the derivative of big F of x equals little f of x. So the two ways to interpret this are, if you had this function and you differentiated it, you would get back to here, our integrand. Or if you take this integrand and take its antiderivative, that would be big F of x. And as usual, there should technically be a plus c on the tail end of this, but when you're doing a definite integral, it's safe to ignore that because you know it would cancel out. If we included the plus c, all that would happen when we evaluate these is we would get 9 plus c. Here we would get 1/3 plus c, and this result would be 27/3 minus 1/3 plus c minus c, and the c's would cancel out. And because we know that's going to happen, we just neglect them and just concentrate on the numerical answer.